Hello, this is Roel Marano and this is my report on organic chemistry in amides. What are amides? Amides are derived from carboxylic acids. A carboxylic acid contains the -COOH group, and in an amide, the -OH group part of that group is replaced by an NH2 group. Primary amides are named by changing the name of the acid by dropping the -oic acid or -IC acid endings and adding amide. In the middle is an example of acetamide, and the third one is benzanamide. Secondary amides are named by using an uppercase N to designate that the alkyl group is on the nitrogen atom. Tertiary amides are named in the same way. For example, is the first structure named N-methyl propionamide. Preparation of amides. Amides are made from carboxylic acids and acid chlorides. The carboxylic acid is first converted into an ammonium salt, which then produces an amide on heating. The ammonium salt is formed by adding solid ammonium carbonate to an excess of the acid. For example, ammonium ethanoate is made by adding ammonium carbonate to an excess of ethanoic acid. When the reaction is complete, the mixture is heated and the ammonium salt dehydrates, producing ethanamide. Acid chlorides. In the first stage, the ammonia reacts with ethanoyl chloride to give ethanamide and hydrogen chloride gas. Then the hydrogen chloride reacts with excess ammonia to give ammonium chloride. And you can bind both to give one overall equation. Reaction of amides. There are 5 reactions on amides: hydrolysis with nitrous acid, reduction, Hofmann degradation, and hydration. First is hydrolysis. Used in concentrated acid, HCl or H2SO4. Its products are ammonium or ammonium salt and carboxylic acid. These are some acidic hydrolysis equations. Next is an alkaline hydrolysis reaction. Concentrated sodium hydroxide are used, and its products are ammonia or amine and carboxylate salt. These are some general equations on alkaline hydrolysis reactions. Second is with nitrous acid. Amides react with nitrous acid, HNO2, to give carboxylic acid, NH, and N2 gas. Nitrous acid is unstable and is prepared in site by the reaction of dilute HCl or dilute H2SO4 with sodium nitrite in the absence of heat. For example, this is an example of amide to carboxylic acid and ethanamide to ethanoic acid. Third is reduction. Amides can be reduced to amine by conversion of CO to CH2. Amides can be reduced by lithium aluminum hydride but not less reactive than sodium borohydride. Look at the N substituent in the following examples. Those bonds don't change. Here we can see lithium aluminum hydride reacting with the 3 amides, and we can observe that the CO atoms change to CH2. Fourth is Hofmann degradation. Hofmann degradation is a reaction between an amide and the mixture of bromine and sodium hydroxide solution. Heat is needed. The net effect of the reaction is a loss of CO, part of the amide group. You get a primary amine with 1 less carbon atom than the original amine had. Here is a general equation. An example is ethanamide to methylamine. This is the full equation of the following reaction. The Hofmann degradation is used as a way of cutting a single carbon atom out of a chain. Lastly is dehydration. Amides are dehydrated by heating a solid mixture of the amide and phosphorus oxide. Water is removed from the amide group to leave a nitrile group. The liquid nitrile is collected by simple distillation. For example, with ethanamide, we'll get ethanenitrile. Here is the example equation. That is the end of my report. Thank you for watching.